logs and exponentials are tied together. Okay, so we've been talking about exponentials, y equals a to the x. All right, to reverse that, log a of y equals x. Okay, so they are tied together, and that's how they're tied together. All right, so you need to keep this in mind when you're messing around with this stuff. Okay, so if you've got a to the x and you're trying to find x, you need to do log a of y. Okay, to find that value. All right, which makes sense. If you actually do this with numbers, it will actually make sense. So if we had 16 equals, what's that, 2 to the 4? I think. Is that right? 2 times 2 times 2 times 2, 16?
Yeah.
Yeah. So 16 equals 2 to the 4. Okay, so now if we say, okay, if we're reversing that, log 2 of 16 is 4. Right? So what that means, what you're asking when you're logging to the base 2, how many times does 2 multiply by itself to get 16? Or what would I put 2 to the power of to get 16? The answer being 4. Okay, that's what that function means. All right, it's kind of like square root, but for all sorts of powers. Okay, so instead of just saying what number multiplies by itself to get this, this is what number multiplies by itself this many times to get this. All right, so like index laws, there are a whole heap of nice, cool rules when it comes to logarithms. Okay, so because this is an index law thing, okay, these exponents, these exponentials, you can mess around with index laws with them. Now we're going to talk about how those laws sort of transfer over to here. All right, so log a of m times n is log a m plus log a n. Okay, so you can separate them out. So if you're adding two logs to the same base, you can multiply them in the one bracket, or if you're multiplying them, you can actually split them out into a plus if you want. All right, so that can go both ways. Don't forget they can go both ways. All right. So to clarify where that comes from, what happens when you're doing something to the power? So a to the m plus a to the n. What do you do? Sorry, times, isn't it? You add them, don't you? So if you're timesing, you add. If you're timesing, you add. All right, so they tie in together. They come from the same base. All right. So if we're doing log a of m divided by n, what do you think that's going to be? Given our index laws, okay, you subtract them. Spot on. So log a m minus log a n. Okay, with the m being the first one, so the top one is the one you subtract from. All right. So again, that ties into our other index law. I won't write that down. Log a m to the n. Now this one is a bit different. All right. Log a m to the power of n is the same as n log a m. Okay, so it's just the same as times by that value. So you just sort of zip that power out the front and you're done. Okay, that's basically what that one means. Log a of a is 1. Okay, how many times, if we go back up here, how many times does 2 multiplied by itself to give 2? 2 multiplies by itself 1 times to get 2.
2.
All right. It doesn't quite work like that, does it? But if you're doing log to the base a of a, then it's 1. Okay, it just comes out as 1. Sorry? Yeah. All right. And log a of 1 is always 0. Okay. Relate that one to a to the 0 equals 1. All right. Relate this one, a to the 1 equals a. That's how they relate together. That might help you understand where those two come from. Okay, so some examples of that stuff in action. We already did this example before. Log 2, 16. What is 2 to the power what power would I put 2 to get 16? So 4. All right, that's how you do that. Without a calculator, what power do I put 2 to get 16? And it's 4, so that's your answer there. This one we're using our rules. All right, so back here, if we're adding these guys here, we multiply, and we can multiply it in the middle there. Okay, so if we just go log 2 8 by 10. Okay, so log 2 of 80. All right, which you may be able to simplify a little bit if you think carefully about it. All right, so I'm not sure how much further they want you to go in the book. They do. No, they want you to stop there. All right, so we won't go any further. Next year probably will. All right, so now let's have a look at question 8. 8 gets a little bit sketchy. We'll do A first, and then we'll work up to E and H. All right, so 3 log 10 5 plus log 10 2. What am I going to do? What rules should I use? To give you a refresher, here are your rules. All right. Probably can't see them alongside. No, can't see them alongside the question. All right. But when I'm looking at this, the first thing I notice is there's a number here, all right, which is multiplied there, which I don't like. I don't want it there. So you can do the reverse and bring that up there. Okay. So the first step I'm going to do is log 10 5 to the 3 plus log 10 2. All right. 5 to the 3 is 5 times 5 times 5, which is log 10 125 plus log 10 2. Yep. So now I just multiply them to get log 10 125 by 2. So my final answer, log 10 250. All right. So now if you want to do 8e, okay, yeah, so e is 1/3 log 227, minus 1/2 log 236. Okay. So this ties in all your index law stuff as well as adding in your new log stuff. That's why you're having trouble with it. So again, these two here are multiplied and I'm going to zip them straight in. That's my first step. Okay, so log 227 to the 3rd minus log 236 to the 1/2. Now, to the 3rd means what?
Cube root.
Cube root. So what's the cube root of 27? Yep. What's 1/2 mean? So it's the square root of 36. Now what do I do? Divide. So log 2 3 on 6. Log 2 1 on 2. And do I need to go any further? No. Right, we can stop there. Okay. Does that make sense?
Yep.
Do you think you could do H on your own now?
No.
No? Still want me to do it?
Yep.
Okay. Alright, so 2 log 10 x plus 3 minus log 10 x minus 2. Alright, again, first thing I'm going to do, log 10 x plus 3 squared. Alright, minus log 10 x minus 2. Alright. What do I do now?
Do you do the divide?
Yep, so you divide
So
log
x
10
plus 3 on the top.
x plus 3 squared divided by x minus 2. That's as far as you need to go.
I thought we would have to do
Alright, you can go further. If you really, really, really wanted to, I'm sure you could expand that and then divide by that using all your quotient stuff that we did before, your long division stuff, but you don't need to go further. It says simplify, not evaluate. Alright, and that's as simple as you're going to get it. Okay?